All right, so in this video, we're going to look at how to conduct a test for independence on a contingency table or a two-way table, a chi-square test. So the first thing that we're going to look at is our data and our example. So in the table below, we are looking at the terminal degree type and age of employees at a local manufacturing plant, under 40 versus over 40. And we have three degree levels: high school diploma, undergraduate, and graduate. We want to use a chi-squared test and a 1% level of significance to determine if age and terminal degree type are independent. So essentially, do the same proportion of people have essentially different degree levels, regardless of which age category they're in? So our procedure is that we're going to have to enter this data from our table into a matrix in our calculator, and then we can use the chi-squared test of independence in our calculator to perform the calculations for us. So to enter the data into the matrix, we're going to press the second key and then the x to the -1 key. Now, the x to the -1 key, if you're looking at your calculator screen, it's the fourth row down, right below the math key. You'll notice that it says matrix right above it. So second, and then that x inverse key is going to get us into the matrix menu. Now, some very old calculators will have a specific key for the matrix, very, very old calculators, but most of the 83s and 84s that were released in the last 10, 15 years, this is how you get into the matrix menu. And then you're going to use the arrow key to move over to the edit menu. And from there, you're going to highlight the first matrix. You can put these in any matrix, but to save yourself some typing, choosing the first one works just fine, and then press enter. Now, at the top of the matrix screen, they're going to ask you for the dimensions of the matrix. And essentially, we're going to need to enter essentially the number of rows and the number of columns in our data table. So if we go back to the top, we have 2 rows. So the rows are the number of lines essentially in our table that have actual data in them. And then the columns are these. So here we would have 3 different degree levels, and so 3 different columns. So this is a 2 by 3 matrix, 2 rows by 3 columns. So when we enter this into our matrix, we're going to enter 2 here, and then scroll over or hit enter, and then 3, and then again hit enter or scroll over. And then that will set the dimensions of the matrix. And then inside the matrix, we're going to enter the data from our table. It is going to, by default, every time you hit enter, it's going to scroll over to the next row, the next column in the same row. So when you hit 42 and enter, it will scroll over to the position here, and then you would hit 54 and then enter, and then it'll automatically scroll over to here, and you'll hit 21 and then enter, and then it'll automatically drop down to the next row, and then you would hit 68 and then enter, and then you would hit 34 and then enter, and then 15 and then enter, and then your matrix will be complete. So then you're going to want to get out of the matrix menu. So second, quit, which is above the mode key, and then press stat and scroll over to the test menu. And the chi-squared test is actually way down at the bottom. So it may be easier to scroll up in order to find it than scrolling down, but it is row C, the chi-squared test. Now, the goodness of fit test is a different test. It is also using the chi-squared distribution, but that's not the one we want. We want the sort of general chi-squared test right under the 2 proportions Z interval. And so either scroll down, or you can hit C, which is alpha, and then the program button. Or as I said, you could scroll up and you find it from the bottom. But that's the chi-squared test, and then hit enter once you've gotten there. Now, the screen that's going to come up is going to look something like this. Older calculators won't have the color option on there, which is fine. You can ignore it. In the menu that comes up, you're going to need to specify which matrix your observations are in. And we entered our data into the A matrix, so we should type A here. And you can use the alpha key to get the letters. A is above the math button. Sometimes when you go into this menu, the alpha key is already activated. And so if you just hit math, then it will automatically specify A. You may need to experiment with the settings on your particular calculator. And then B is the character just over from that above the apps key. Now, A and B are sort of the defaults on here, so you may not need to change these. The calculator is going to calculate B for you, so you don't need to have pre-calculated B. And then when you've entered the matrix where your data is stored and you have a place where the expected matrix is going to go, then you're good. You can scroll down to calculate and hit enter. And again, the color here is more for the drawing option than for anything else. And older calculators won't have it. And then finally, when you hit enter and when you hit calculate, then you're going to get this information on the screen. You're going to get the chi-squared test statistic, the p-value that was calculated, and the number of degrees of freedom. The degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So 2 rows, 2 minus 1 is 1, 3 columns, 3 minus 1 is 2, 1 times 2 is 2. So that's the degrees of freedom. And then the p-value is the thing that we're really looking at. We want to compare this to a 1% significance level. This is less than the 1% significance level. So we can say there is sufficient evidence to suggest that the age of employees and the terminal degrees are independent on each other. In fact, if you look at the data, it would suggest that older employees are more likely to have a high school diploma than an upper level degree, whereas younger employees are more likely to have some sort of degree beyond high school.